Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today I'm covering a topic that I've been looking forward to for some time, and that is, what is the ASi network? ASi is a topic we've never covered on this channel, and it's a field bus that I've always been fascinated with. It's been around a while, but it's very clever and does some things much differently than any other field bus. And I think you're going to enjoy learning about ASi today. So without further ado, let's get right to it. We're going to start today's program, as you'd expect, with an introduction to ASi. We're going to talk about how it's unique. We're going to talk about its system architecture and its messaging. What are the advantages and disadvantages of ASi? And then we'll walk you through ASi setup. We'll show you how to connect it to a Horner all-in-one controller. And of course, there'll be plenty of demonstrations. Here we go. So what is ASi? Well, the full name of ASi is Actuator Sensor Interface, sometimes shortened to AS Interface, often shortened to ASi. Now, I've always pronounced it ASi. I don't even know if that's officially what you're supposed to do or not. But as its name suggests, ASi is a network that's designed around interfacing sensors and actuators to PLCs and other controllers like the Horner OCS all-in-one controller. And as I mentioned in the open, ASi offers several unique approaches to interfacing those sensors and actuators, and it starts from the cable on up, as you'll learn here in a few minutes. Let's start talking about how I/O is traditionally wired to control systems, sensors and actuators, of course, and then we'll be able to kind of demonstrate how ASi is different. Okay, so obviously, or as most of us already know, with traditional I/O, each sensor or actuator is hardwired back to a PLC I/O module. Now, whether that PLC I/O module is snapped directly into the side of the PLC, on the back of a Horner OCS all-in-one controller, on a piece of remote I/O, again, it's hardwired, and there's quite a bit of wiring labor that's required there. Now, field buses were invented to reduce some of that wiring effort, especially when it came to remote I/O. Okay, so with field bus I/O, every sensor or actuator is connected to the field bus remotely, either directly to the field bus, as some intelligent devices do, or maybe through a field bus I/O block. Now, ASi follows that field bus approach, but with a unique wiring scheme. Let's start talking about that now. One of the things that makes ASi extremely unique is that it uses a flat two-conductor field bus cable that supports both data and power. Okay, that's very unique. Not too many flat cables out there. Also, ASi uses cable piercing technology as you're adding devices directly to the field bus itself. So you're not cutting and terminating wiring. You are basically placing the devices directly on the flat cable, and that device is built to pierce through the cable. Very unique. Now, again, devices can be added directly to the cable itself, or you might have an interface that's wired directly to the flat cable itself, and then use something like an M12 to connect it back to the sensor. Now, for ASi devices that require significant power, like output devices that are more than just LED lights or something, for instance, there is a second flat cable, which typically is black. Your standard ASi cable is yellow. It carries basic power as well as the network connection. And then the black cable is what's used for output power for those devices that take more current. Now let's talk about system architecture. The ASi master typically interfaces with a PLC through a field bus. So yes, ASi is a master-slave network and it requires a master, okay? In addition to that master on the ASi network, you also need a special DC power supply that's connected to the ASi master to provide the power to the network, okay? And that power can be up to 4 amps. There are definitely also ways of getting that power up to 8 amps as well. Now, when it comes to distance, ASi can support up to 100 meters, which is a pretty decent distance, all right? And it can support a maximum of 62 devices, in addition to the master, of course. One of the really unique things about ASi is the fact that it supports all kinds of different topologies, not just linear or daisy chain. It also supports star and tree, for example. All those are supported. And in most installations, you don't need any kind of termination either, which is also very unique to ASi. All right, now let's start talking about messaging. ASi, as I mentioned briefly before, is a master-slave network. Now the communications is serial and cyclic, and there's a carrier rate used with typical ASi of 167 kilohertz. All right, now each slave can support up to 4 bits in and 4 bits out. That's another unique thing about ASi. ASi doesn't try and be everything to everybody. It's basically focused on simple sensors and simple actuators. So 4 bits in and 4 bits out for a sensor or an actuator is plenty in most cases. I mean, let's face it, if you hardwire a sensor or actuator back to a PLC input or output, you're at 1 bit per device, typically, if you're talking about a digital device. So again, that's one of the other things about ASi. It's focused on sensors and actuators. Now, as I mentioned before, you can have up to 62 devices on the network. And if you do, in that case, you're going to have 248 bits in and out. But a basic ASi network would be 31 devices with half that amount. Now, you would think when you start seeing specs like 167 kilohertz for a carrier rate, when you see that K for kilo, when you're talking about communication, you're usually thinking S for slow. But that's not the case with ASi. The response time is very good. For a typical network with less than 31 devices on it, you're going to have faster than 5 millisecond response time. So very quick. Plenty fast for nearly every application. Certainly all the typical ones you see out there. Of course, there are some that require higher speeds than that, but very, very many do not. All right, now let's talk about addressing. How do we assign addresses to ASi devices? Well, again, we talked about earlier, there's up to 62 addresses available, and those are addressed from 1A to 31A and 1B to 31B. That's how ASi went from 31 devices to 62 devices. Now, some devices, I think safety devices as an example, require a full address. So they're just going to be addressed at 1, 2, 3, etc. They won't have the A or the B. Now with ASi, addresses are assigned electronically. Okay, so a device comes from the factory, typically with an address of 0 already installed. But of course, you want to install that on the network and change that address to one of the normal addresses. 1A to 31A or 1B to 31B or just 1, 2, 3, etc. Now there's multiple ways in which you can assign the address. You can do that through your master/gateway device. Okay, that device typically has the ability to assign addresses built right into it. You can use a handheld programmer, which is extremely handy and very fast, but it also is an extra tool that you would actually have to source. Or you can do it in software. Okay, so there's multiple ways of doing it, and I'm going to show you how to do it today just using the master/gateway, since you're going to have one of those in every system. Everything I've talked about so far applies to what's called ASi 3, which is kind of the latest version of the traditional ASi with the traditional ASi wiring and messaging scheme. There's also something called ASi 5. Now that's a next generation spec. What does that offer? Well, ASi 5 offers more data capability per node, so much more than just 4 bits in and out, okay? Potentially faster response times with much higher communications rates, okay? However, those improvements do come at a cost. There are much more strict installation requirements, so you no longer have the ability to use any topology you want. You need to have a higher end flat cable with higher capability, and also you need to deal with termination now, okay? So again, for most traditional applications looking to interface sensors and actuators, ASi 3 is just fine. and it's not going away, by the way. But for those more advanced applications, ASi 5 is available, and pretty much most gateways these days support both ASi 3 and ASi 5 devices on the same cable. Okay, so what are the advantages of ASi? And there's quite a few. The direct connection of the sensors and actuators, and it's really pretty easy connection as well, right on the flat cable. That's pretty awesome. Reduced cabling costs versus field bus. Now this is one I wasn't quite sure of. I had to do a little research on this, but when you think about field bus installations, there's a lot of cables involved. I mean, a lot of them are extremely fast to install, M12 style cables as an example, but there's a lot of them and they're fairly expensive, okay? Whereas with ASi, even though you have a specialized flat cable, there's not as many total connections for sure. So the installation cost is, reputed to be lower than your typical field bus. And when you start thinking about labor, then you start to see some savings. You're not doing any cutting and stripping of leads, okay? You do have data and power on one cable, which is pretty cool. Another thing which is pretty unique to ASi, I believe, is that your standard devices and your safety devices can all be installed on the same cable. That's pretty unique. Also, the flexible architecture capability, where it doesn't have to be daisy chain or linear. The fact that it can be a star or a tree, and as long as the distances keep below 100 meters, you're good to go. That's pretty unique. And it goes without saying, for a network that's been around a really long time, that ASi is reliable and noise resistant. And really, that response time of 5 milliseconds or 10 milliseconds is pretty attractive for a field bus. Now, there are some disadvantages as well, and I wanted to cover those here on this particular slide. Now, generally, ASi is really, really good with sensors and actuators. It's not really built and it's not strong at analog. It does support analog, but that's not its strength. Also, it is a bit of a disadvantage that you have to use specialized cabling, the flat cabling, but any field bus requires specialized cabling. If you're talking about, long distance CAN networks, you need special CAN cable. So really all networks have some specialized cabling, but ASi certainly does with its flat cable. Okay, but it's also one of the advantages of ASi is that flat cable. And then another, what I would think of as a disadvantage is ASi 5, while it offers some really nice improvements, it also takes away some of the advantages of ASi by having much more strict installation requirements with ASi 5 than with traditional ASi 3. Now let's talk in a little more detail about how you connect an ASi network to a controller. Now earlier I mentioned the fact that we have an ASi master, typically a gateway, that is going to be running and controlling the ASi network, and then to interface that to a controller, whether that be a PLC or an all-in-one controller from Horner, typically you're going to do that over a field bus or industrial Ethernet connection, usually these days through an industrial Ethernet connection. Now, in the case of connecting the Horner OCS all-in-one controllers to ASi, you're talking about a Modbus TCP connection, and you're going to see response rates typically in the 10 millisecond range. Bihl Wiedemann have been super kind to provide us with the equipment that I needed for today's demonstration. They've been great to work with. I see those guys at trade shows all the time. Really, people think of them as the ASi guys, Bihl Wiedemann, that is. Now, I want to apologize in advance. I'm sure at some point during my demonstrations today, I'm going to probably say Bihl Wiedemann in my American style of mispronouncing German things. But again, thanks again to these guys. Now, they provided not only the ASi devices, but also the gateways, and they offer gateways with and without safety built in, and they also support just about every industrial Ethernet flavor you can imagine. And again, for our demonstration today, I'm using Modbus TCP because that's the easiest way to interface with the Horner OCS all-in-one controller. When using Modbus TCP with the Horner OCS all-in-one controller and the Bihl Wiedemann gateways, there's a simple data map of all the ASi input data. Remember, every node on the network has 4 bits of input data. And then there's also an easy way of interfacing with the 4 bits of output data that each slave also provides. So they're both just mapped to Modbus TCP holding registers. You can see the ranges there at the bottom of the screen for the input data. And then in the middle of the screen at the bottom, you can see the holding register range for the output data. Really straightforward. Also, there is some status information available as well as some command information available through the Modbus TCP interface. And I've got those holding registers identified there on the screen as well. All right, so enough about ASi from a slide standpoint. Let's go ahead and do a couple of demonstrations, or several demonstrations, of setting up an ASi gateway and I/O modules, and then also setting up the Horner all-in-one controller to interface with the Bihl Wiedemann gateway. All right, let's go ahead and take a look at the bench here, and right now we just have our ASi components on the bench. So what we're looking at here is an ASi power supply, okay, connected to mains power, putting out 24 volts DC, which is connected here as ASi power. The gateway has the capability of having 2 ASi networks. It has ASi 1, which is the first 2 connectors, and ASi 2, which is the second connector. We're only going to be using the ASi 1 network today. All right. And then we have a couple of ASi devices, one of which is connected but not yet configured. Okay. The other one is not connected. All right. So here on our gateway, we also have an Ethernet switch. That one is connected to the Ethernet network. Ultimately, it'll be connected to an OCS that'll be, driving the ASi network, or at least, driving the data that goes out over ASi. And then if we take a look at what's going on here, you can see this diagnostic message that's been kind of cycling through some of the different diagnostics that's happening on the gateway right now. All right, so let's go ahead and go into the menu of the gateway. And the way I did that was by pressing and releasing the OK button. And the first thing I want to configure is Ethernet, because I'm going to be interfacing this to the OCS over Ethernet, and I want to make sure that's configured properly. So I hit OK, the OK button here. And as you can see, Modbus TCP is selected instead of Ethernet IP. Now, when I first connected this, when I first entered this menu, neither one of them were marked with an X. So I wanted Modbus TCP, so I basically selected that and enabled Modbus TCP in this part of the menu. Okay. All right. And then by pressing Enter again, all right, I now have the ability to set the TCP IP address, as well as one or more Modbus parameters. Let's go ahead and go into TCP IP. Now, I previously went in here and configured an IP address, so I can see actual values. Now, when it shipped to me, it came with an IP address of all zeros. Okay, and I set it to an IP address that was going to work in my system, along with a net mask that matched what I wanted. And I went ahead and configured the gateway as well, even though, unless this device needs to access the internet, that probably wasn't necessary. Okay, so that's what I want to do there. Now, when you change this, basically what you do is you go to the configuration menu, all right, and then you hit Enter. Well, once you go down, you want to decide whether this is a DHCP or a static address. I wanted a static address. And then you press Enter here, and then when you press Enter, you have the ability to change the IP address digit by digit using the up and down arrows and then left and right to navigate from digit to digit. And when you get all the way, when your cursor gets all the way to the very far right, and you hit the OK button, then it takes that. And then it takes a power cycle or a reset for that to actually change. I'm going to escape out of this because I don't want to change this. Okay, and since I didn't change it, I'm going to cancel a restart here. Okay, all right, and again, I made no changes, so there's nothing to worry about there. All right, so my Ethernet configuration is done. The only thing left is any Modbus parameters. The only thing that is there to be configured is watchdog time. So this is how many 10 millisecond steps I will wait before I decide that the Modbus TCP client in this case an OCS all-in-one controller from Horner Automation, how long I'm willing to wait for that device to talk to me before putting the network into a safe state. Okay, so that's what that's all about. The default is 100 steps of 10 milliseconds or 1 second. I'm happy with that, so I'll just back out here. Okay, so I'm fully done with my Ethernet configuration. Next, let's go ahead and add some devices to the network and address them from here. Okay, so I'm going to go ahead and use the slave addressing tool. Okay, so I'm going to select that choice. Now, there's a lot of ways I can set slave addresses of ASi devices. I can do it from the software package. If you have a license for the software, I can do it from a handheld programmer if you have a handheld programmer. I'm going to do it here from the menu because I've got the gateway, and I know you'll at least have the gateway as well, so you'll have a means of configuring it. All right, so I'm going to select slave address tool. Okay, and I'm going to need to select a network. Now, what network am I going to select? ASi 5 is the latest version of ASi, supports safety and all kinds of other stuff. And it's the latest standard in terms of, data sizes and all those sorts of things. But the devices I'm going to be connected are just ASi 3 devices. So I need to go to ASi 3 Circuit 1, okay? And the first thing it's going to ask me to do is connect new slave, okay? All right. Let's hit OK here. Old address is 0. The new address is 1. Okay, that's what I want to have happen here. Now, another thing you may have noticed there is that the mode, this light here that says PRJ mode, that lit up. Okay, so I just switched into PRJ mode, which is the mode you have to be in to do any network configuration. Okay, so this device is, by default, has an address of 0. I want to give it an address of 1. All right, so old address 0, new address 1. If I scroll down to program and hit OK, it now says OK. All right, so let's back out and see what we see when it scrolls through. Aha, you could see a 1A that was displayed for network 1, ASi 3. It showed a 1A. All right, so we've added device number 1A to the network there. You can just see it again. All right, let's go ahead and get this guy configured. So let me plug him in, okay, to the ASi network. All right, let me get this guy screwed down here, get him connected. All right, there we go. Oops, let's scoot him over a little closer so we can see it better. All right, aha. You saw we had a device 0 that was connected there, okay, for ASi Network 3. All right, so we need to change its address, and let's go ahead and go back into the menu and do that. Okay, so we're going to scroll down to the slave address tool. All right, and again, we're in ASi 3 Circuit 1. Okay, so the old address, we want to connect a new slave. Okay. Okay, the old address is 0, right? Because that's what this guy currently is 0. Now, if you'll notice, this device doesn't take up an A and a B address. It only took up an A address. This device requires a full ASi address. Okay, so the first fully available ASi address is 2. All right, so that sounds good. Let's go ahead and leave it at 2. So the old address is 0 for this device. The new address is 2. I'll hit OK after I highlight program. It says OK. All right, now let's escape out. Okay, and see what we see here. All right, we have 1A and 2 on that network. So that's what we're after. Okay, now let's go ahead and test this I/O. And to do that, I'm going to do that actually from the web tool. What we're looking at here is my computer, and I just have a web browser running. And I've tapped into the built-in web server with diagnostic information in the gateway, just by typing in its IP address here in the URL line. Very handy. Now, before I can test the I/O on the slave devices I just added to ASi, I need to get out of configuration mode and get into what they call protected mode, which I guess is the equivalent of run mode. Okay, so from the gateway tab, I'm hitting the save and protected mode button here. That puts me into protected mode or run mode, if you want to think of it that way. And when I go to the home tab, you can see, hey, look at this. ASI Circuit 1, I'm showing my two ASI 3 slave devices, number 1A and number 2, and the current state of their 4 inputs and their 4 outputs. And if I want to go ahead and test those, I can do that now. So let me go ahead and click on the first one, all right, which is our 2-position push button station. I just pressed the first input button and released it. Now I'm pressing the second input button and releasing it. That's working good. Let me go ahead and change the outputs. And by doing that, I'm going to change the color of the LED. So you can see that's changed. Okay, so that's now white instead of being off. All right, if I change it again, it should change color again, which it did. Now it went from white to red. Okay, and I can do the same thing with my other LED. Now they're both red. Okay, so you can see, it looks like everything's working as expected. Very cool. Currently, my e-stop button, everything's good. So we can see that our, if we go back out to the other, let's turn these off first. Okay, if we go back out to our other circuit, or our other device, number 2, we can see the inputs are currently both on. If I hit the e-stop button, you can see those inputs turned off. Okay, very cool. I'm not sure exactly what the outputs do on this particular device, but certainly if I rearm my e-stop button, we can see the inputs turning on again. All right, very cool. All right, so using this handy dandy web server, which has these great diagnostics associated with it, I can quickly and easily test the devices on my network without having to worry about, is the Modbus part of the system working or not. We're going to work on that next. All right, now let's go ahead and set up the Horner OCS all-in-one controller to exchange data over Modbus TCP with the ASI gateway. So whenever we're talking Modbus TCP as a client in a Horner OCS all-in-one controller, we start from hardware configuration. We go to the LAN port that we're talking over. We go down to downloadable protocols and select Modbus client from the drop-down list. And then we have 3 levels of configuration. In the first level, the only things I change from default are retries and timeout. I typically go with 2 retries with Modbus TCP. I typically shorten my timeout down to ½ a second. I also shorten my reacquire time down to ½ a second. So if we have any kind of communications issue between the OCS and the gateway, we don't wait a super long time on a timeout. We can just keep retrying. Okay, I leave the scan rate at as fast as possible by setting the update interval to 0. And then I assign a disable bit, which allows me to totally disable Modbus TCP on the OCS side of things. I could use that kind of as a mock reset if I ever need it. I doubt I'll ever need it, but I assigned it anyway. And then I assigned this status variable, which is 4 consecutive double integers in an array, which tells me important information such as my pull time, how many good messages I've gotten, as well as any bad messages or no responses. Very important there. Okay, so that's the top level. On the device level, this is where I tell the OCS about the device it's talking to, which is the ASI gateway. I plug in the IP address. I leave the addressing scheme at Modicon PLC 5-digit addressing because that's what the gateway uses. I can also assign a disable bit to this slave, where when it's on, the OCS will not scan it at all. Don't think it's all that useful in this case, but I assigned it anyway. And then I have 2 additional words of diagnostics specifically tied to the slave. And again, when diagnostics are available, take advantage. If you have a problem, you're going to want to use them. And then finally, the last level is the scan list. This is the data we're going to be reading and or writing between the OCS and the gateway. Starting on the read side of things, this is that Modbus holding register address for all the input data from the ASi devices, and we have 16 words of it maximum. Now, if you have a small ASi network, you may not need to read all 16 words, so shorten this if you can, okay? But I left it at the maximum of 16, and it's a polled read. And this is the word type input array where all the data is being read into in my logic program. Okay, so that's on the input side of things. On the output side of things, I had to do something a little bit special, and I'll describe that now. The device register or the holding register number is the same as what I showed in that chart during the slides. However, the gateway does not support, for some reason, it does not support writing a single holding register at a time from the Modbus client. It only supports writing multiple holding registers at a time. So to force the OCS to write more than 1 word at a time, I had to check this check mark that says 32-bit access. So that means even though I start at the same holding register number, my length is half as much because each of the lengths is in 32-bit values, okay? And the variable that I'm writing data from is an array of 32-bit data, not 16-bit data, okay? So a little bit of a subtlety there, an important point to get communications working properly the other direction. And this isn't just a polled read, this is a read-write, and I chose the init choice so that on power up, the OCS will write data to the gateway and then go on a regular polling routine from there. Okay, so that's the Modbus TCP configuration in 3 levels. All right, other than the Modbus TCP configuration, you know, I built a screen here, actually built a couple screens. This one showing me the status of the devices and allowing me to do some level of control. I can change the LED color on the push button station. All right, and then I also built a screen that basically allows me to do diagnostics from a Modbus TCP standpoint, as well as looking at a little bit of ASi data coming in over Modbus TCP. And then finally, I have a little bit of ladder logic. At the bottom of that routine, I'm building a Modbus TCP OK bit. This logic is really just checking to make sure that my number of good messages is counting up. And if it is, then I know I'm okay. If it's not, I know I'm not. So I've got that indicator to work with. And then up here at the top, I'm doing nothing more than basically writing some data to some of the output bits on that push button station to control the color of the LED. So that's all that's happening here. All in all, not a lot of effort from a configuration standpoint. Now, through the wonders of pre-recorded video, you can see I've now added my Horner OCS all-in-one controller to our ASi demonstration here. Between our ASi slave devices, which we just configured, and our ASi gateway. We've also, of course, got our ASi power supply. Now, of course, as we just mentioned, the ASi gateway is controlling the slaves directly at a high rate of speed, probably an update rate of about 5 milliseconds or so. And then all of the ASi input and output data are being exchanged over Modbus TCP, also at a pretty good rate of speed, about every 10 milliseconds or so. All right, and I've got a demonstration here on the screen. So as I press my buttons, you can see the start status show up here on the screen. Same thing there, nice snappy response time. Now in my demo, I chose not to reflect this color here on these buttons. I certainly could have done that. But I do have the ability to change those button colors from this device here, from this selector switch. Okay, so that capability is also working nicely. And then on my e-stop button, you can see it's all green, everything's good. When I trip it, you can see that status is reflected on the screen. And then when I reset it, everything goes back to normal in a nice snappy fashion. All right, I've also got a status screen where we can monitor the Modbus TCP master and slave status. That's all looking good. Snappy response time, lots of good responses counting up. Zeros on the slave status is what we want. And then I've also chosen to display some of the ASi data here for the input data and for the output data, which of course is read-only and read-write respectively. All right, everything's looking good. So, and it was really pretty easy to put together. So that does it for our topic for today. Here's a reminder, we have basic and advanced courses available during the fourth quarter, so sign up early on our website. Also, lots of opportunities to see us out in the field. We're going to be all over the Midwest and the South in the third quarter this year. Come and visit us. We'd love to show off some new products. Lots of ways to interact with Horner Automation online on our YouTube channel, as well as our website, and don't forget about LinkedIn. Now, we've got a big event coming up later this week, Thursday to be exact, where we're launching our new modular controllers. We've got a launch webinar at 2 o'clock Eastern, which is kind of our normal time, but you will need to sign up online. It's not just being broadcast on YouTube. So you can see the URL there on the screen. Sign up today. This is going to be a really exciting introduction of these new modular controllers. If you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Now, we just passed 2,000 subscribers this week. Thanks for that to everyone who's subscribed. And hopefully I'll see a bunch of you on Thursday for the big product launch on Big Marker. All right, so until then, let's all get out there and do some good.